with VerifySoft, we have one product that Paulina already mentioned in her introduction, that we have a code coverage analyzer called Testwell CTC++. This is our major tool, and myself, I'm working as a technical consultant for VerifySoft and try to help customers get familiar with the tool, so bring them to the basics and the first steps. So this is a very lightweight tool, but it can be set up in very complex scenarios. So for today, I want to give you an introduction so that you can assess if this is something you may want to take a look into it. So it's not in all the details there. So when we go to the code coverage analyzers, so what we do with code coverage analyzer is, so you have software, you test your software, and you want to see if your test reflects all portions of your code. So is everything tested of your code? And you will find a lot of tools when you ask Google or you ask ChatGPT, what are good coverage analyzers? And here are 5 bullet points to give you a hint what maybe if one of these aspects is interesting for you, then our tool can be interesting for you as well. So let's go through the list. CTC++ can be used on all embedded targets, not only for embedded targets, but this is our major use case with our customers using the tool. So you develop your software on a host PC, or you build it on a build machine, but at the end, in this use case, you want to run it on an embedded target, and you want to test on the embedded target. You want to measure the code coverage when executing the tests against the application under test on the target. And that's a task that not a lot of coverage analyzers do. We, in the second point, we have, we see that we can use our tool with almost every compiler. So the tool is a standalone tool. So we do only measuring code coverage. We are not bound to a unit test framework to something else. So we measure code coverage, and we can do this from, it's not only a technical aspect here, it's also a commercial aspect. So if you purchase a license from Testwell CTC++, you can use it in today's project with the GCC, and maybe you have tomorrow a project with IAR, or with CL compilers. So it's not bound to anything from the license one, and from the technical one, it's can be configured by configuration, so that we can adopt our tool to almost every compiler that is out in the market and those that come. So it's very interesting to make this invest in such a tool, especially when you are a software development company that is running different projects for other customers, let's say. The third point is a very important point, that we are compliant to safety critical standards. So so Martin already mentioned it in his presentation. There are different coverage levels, and we know a higher one is MCDC coverage, and not all of the tools can measure such a high coverage level. So the levels we can measure with CTC++ are all the coverage levels that are demanded by the standards out there in the safety critical standards from aerospace, automotive, and railway, and so on, functional safety. A second point with complying to safety critical standard is not only about the coverage level we can measure, but also that we have a certificate for our tool that allows you to use the tool without further qualification. And if you, let's say you're in the aerospace industry, we also support that you qualify the tool. So you have to take into account that whenever you are in the safety critical standards development, you have to do such an assessment if you are allowed to use this tool, if you can use it safely. And that's where we help you with a certificate or with support on qualification of the tool. Embedded targets is our main target of the application of measuring. And when we look at embedded targets, we see that the industry tries to, or that you don't have so much memory, free computing capabilities on such targets. So it's very important that we are able to use our tool in a way that we have a low instrumentation overhead. I explain you later what the instrumentation overhead is. So that's the method how we measure code coverage. Our tool is available for C and C++. These are the core languages, development languages we support. We have add-ons for Java and C#, but for the embedded target market, which is our core market, C and C++ is over 80% in the market. So that's where we focus on. And now let's go to the to some slides how the tool works. Testwell CTC++ is one product, but it's more a product suite. So it consists of several mainly command line based tools that are over 30 years old. So when you listen to Paulina, our company is 20 years old this year, and the tool is older than our company because the guys from Finland, the company Testwell, that's where the name comes from, they started to build this tool, and the basic concepts are still there. And to have a command line based tool is nowadays more important than it was 10 years ago, because everyone wants to centralize their build environment and run things on build machines that don't have a UI anymore. And as we have mainly command line based, not only, but we can use every use case in our tool on command line, if you like. Therefore, it's very easy to integrate it into your development tool chain. And the process of developing a tool from the perspective of measuring code coverage looks a bit different. So what we do when we want to measure code coverage is first we have to instrument the code, and you see in the box below some of the tool names out of this suite. And if the application is successfully instrumented, we have built the application under test. Then we can test this application. That's the second necessary important step, but it's an independent step from the first one. Can be on a different target, on an embedded target. You instrument on a host and you test on a target. And maybe you do the reporting, the third step, back on the host with other tools. The box in the middle has a white background. It should emphasize that we are really independent from the environment. So we don't care what your unit test framework is or how you do your integration tests and what compiler it is and so on. So we are, as long as the application is instrumented, we can measure code coverage. And how we do this is something I show you in the next slide. Here's the normal development process. You have some, let's say, C code. You compile this code, you get an executable, you test your executable, and you get test results. And hopefully all the test passes. If not, some fail. It's not a big deal, but the important thing is this is totally independent from the coverage. So if you have 100% failure in your test results, you still have some coverage. Maybe it looks high, but it doesn't matter. It's not coverage is not a mean to tell you something about the quality of your tests or the quality of your software. It's only a measurement. Do you have enough tests for in respect to your source code? So let's go into the sample. Now we have this classical development process. Now we want to measure code coverage. Let's go in step one in the instrumenting of the code. Let's take the tool CTC on a host PC and let CTC control your compiling process. And CTC will ask the compiler to pre-process the code first. And if you have, for example, a decision like if A is lower 10, if you have this comparison in your code, and you want to instrument your code to measure decision coverage, then this line of code will be replaced in the preprocessed code by this one. So your original source code will be kept untouched, but we make a kind of a copy. And instrument your code. So you see, this is the one kind of the instrumentation overhead. So we still have the same decision in the code, but we have enriched this line of code to be able to count how many truths we have, how many false we have from this if. And that's the way in general how CTC works. So this is end of instrumenting, that we have an instrumented application with runtime, and we have a second artifact that's a file, mon.sym. That's a file where we record all the things we did with your application, and it's by design that it is outside of your application, because we want to keep the instrumentation overhead as low as possible and keep this anywhere. Somewhere else, then we can bring this to the target if it's a target application, or we run our application now on the host, executing some tests, and as the application is instrumented in our second step, the testing, file is generated, a mon.dat file that contains some counter values. So this is the easiest possible workflow. The third step, we use a tool, let's here in this example, CTC report, and build an HTML report. And the HTML report can look like this. So this is our standard design. This can be different. You can make adaptations on your own, and we can also modify the hierarchies we see here. This can be directories and files, or if we have a smaller project, we have chosen here the files and functions view as an overview. We see a file regulator C containing, it has some functions inside. We have an overall MCTC coverage for this file that is 69%. And for function lights, we have 6 out of 8, 75% coverage for MCTC. And when we do a drill down to the source code view of our report, you can see your original source code on the right-hand side, and you see the counters that were evaluated here. So we have 1, 2, 3, 4, 5, 6, 7, 8 counters. So that's the 8 here. And we see that 2 counters are still 0. That's why we only have 6 out of 8 counters. This is the coverage we have. And we can easily see for statement coverage, there's 1 spot missing. This obviously this statement here. So nobody turned the lights off, because we can have here the function lights with the argument goal with 3 values that are compared here. We have off, on, and dimmed. And for MCTC, this would not be enough. This one additional test case, we would also need one that tests something when goal is something different than off, on, and dimmed. This kind of a hidden branch of these construct here. So this is how a report looks like, and it should give you an impression how easy it is to read such a report. Yeah, as mentioned earlier, it's important in safety critical development that you are allowed to use such a tool in your process. And with the new release, version 10, that we launched in December last year, we have achieved also a TÜV certificate, with the mark functional safety, so that you are allowed, if you're from the automotive industry, for example, for ISO 26262, you can use this tool without any further qualification for any ASIL. So it's up to ASIL D, which is the highest level in the automotive sector. Okay, so let's sum up a little bit. We have integration to IDE. So if you want to launch or launch the coverage measurement from your IDE, you can start it with some additional tools that integrate CTC in the menus of your IDE and also integrate in the workflows in your IDE. We have also a lot of use cases where you integrate it in workflows that are not based in your IDE, but on a build machine or somewhere else. As mentioned, we can use it on almost every target with every compiler. And if you are interested in our tool, you can evaluate the tool. It's a free evaluation. It's only consuming your time if you do so, with full support. So this is not a tool that is not that is supported by community and anonymously in the web. You can ask our support team, and it's also an important part of evaluation to see how we guide you through the first steps and to the things that may become difficult when we look on your individual build mechanism. And you see we have some trainings. You're interested, you can look at our homepage. So that's for the moment everything I want to tell you to our coverage tool.